So I was recently hanging out on the OpenShift users Slack channel, and there was some questions around using the Nginx Ingress controller with OpenShift. Now, this is obviously possible. OpenShift is just Kubernetes. You're always going to have routes. The routes are provided by the OpenShift API server, so they're going to remain there. But you can use the Nginx Ingress controller in addition to routes if you like, and you can create ingresses and not have them become routes. I'm going to show you how to do that in this video. We're going to look at doing it through the operator hub, installing the operator, configuring the operator, and then we'll create an ingress for Grafana, and we'll just see how that goes. So we'll jump over to my OpenShift install. So the first thing we're going to do is go to the operator hub over on the left, and then you just want to search for Nginx, and we can see that we have the certified Nginx Ingress Operator. So we'll just go here and we'll go through install. The install namespace can be Nginx Ingress, that sounds great, and let's install that. So that's installing now. Once that's installed, we'll configure it, and then we'll go ahead and create an ingress for Grafana. We'll add the OpenShift environment as a backend for HAProxy so that we can get to it, and we'll see how it goes. Okay, so once our operator has been installed, we can go down here and create an instance of it. So we're just going to call this one OKD. So here we're going to use kind of deployment, but we could use daemon set and run it on all the nodes in the cluster. In this case, we'll just use deployment, and we'll set the number of replicas to 2. So we need to look for replicas. Replica count, so we'll just change that to 2. Ingress class, so we'll set ingress class here to Nginx Ingress, and we'll just do a create there. Okay, so that's creating a deployment. Now this is going to fail because it doesn't have permissions to actually run on this cluster. So we need to sort out those permissions, right? So if we look here, we can see down here we get these errors. And it's probably easier to see if I take you to a terminal. So on the terminal, if we do oc get deployment, we can see that we have the deployment here now. And if we do get deployment YAML on this one, we can see down the bottom here, we have a bunch of errors related to permissions. So it's unable to validate against any security context constraint. So it can't add the value netbind service, it can't use the UID it wants to use, it can't use privilege escalation. So we can see here it's trying to use privilege escalation. So it needs more permissions than what OpenShift is allowing for this to run. So there's a few ways we can get around this. We can try checking the service account that it's using. So you can see the service account here is Nginx. So if we do OC ADM policy add SCC to user in the Nginx Ingress space, for the Nginx Ingress user, any UID, so yeah, we could go through and add a few of these. Let's just add privileged, and we'll just see if that's enough to solve the problem here. So we'll just try and change something and just trigger an action from this controller, and we'll see if it's able to do anything now. Take a look to see what errors we're reporting. Okay, so we can see that the errors are now gone from the status. So let's do OC get PO, and we can see that it is now creating that pod for us. If you see get events, we can see that this is where we had the error. Right, so now the problem is that it's trying to use the type of load balancer, but it's not going to be able to create load balancers in this environment. So let's get Nginx Ingress. So we have a look at this resource. This is the one we just created. So we're just doing it from the terminal now. Nginx Ingress. So we can edit this. Oh, edit twice. So we can edit this and we'll go through and we'll change the things that I think need to be changed here. So type load balancer isn't going to work. So let's do NodePort. And let's just see if that changes anything for us. So you can see here I've changed the type from load balancer to NodePort. It's deleted the load balancer and it's scaling to 1. So let's do OC get SVC. We can see now that it has created the NodePort. Okay, we're still crashing, so see logs. This one, let's see why we're crashing. Okay, so we're crashing because we don't have this default server secret. So this should be our default TLS certificate. So let's just edit that Nginx Ingress resource again. So what if we don't give it anything? See what happens if we don't give it anything now. Okay, so now we're creating this container down the bottom here, and now it's running. So now our Nginx Ingress controller is running. OC get ingress class. We can see that we have an Nginx Ingress class. So now we can go ahead and create an ingress. Now, I'm not sure what effects removing that default TLS certificate is going to have, but let's see if we can create an ingress now. So I think I have some ingresses that I can use. So let's take one of these ingresses here just to save me typing it. So we'll just steal this one. Okay, so we've stolen one from somewhere else. We don't want to do any TLS in this case, so we'll remove TLS. Okay, and the next ingress, that's right. So we're going to do OC project monitoring. OC get SVC. Let's just check the name of our services here. So it's actually Grafana service that we want to send that ingress through to. So let's change that. Name of the service is Grafana service. And the port is 3000, not 5000. Okay, so let's do OC create-f Grafana ingress. Okay, so now we've created an ingress. We can see that we've got the ingress created there, and it's been created on the Nginx Ingress class. So let's go back for a second to Nginx Ingress. So look here, and let's exec into one of these pods for a second. Okay, so in this pod, okay, let's try Grafana from Nginx. Okay, so we can see that we now have a Grafana ingress conf that has been created on the Nginx pods now as well. So we know that the ingress controller itself is working. So we have a look at that. Yeah, so we have a look at that, we can see that it's configured everything how we would expect it to have configured it. So that is great. So let's go back to our cluster now, to OC get SVC. So what does this mean? How are we going to access that? We can see that we're using the node port for our nodes. So this means that all of the nodes in the cluster are listening on these ports. Now we're doing TLS pass-through in this case, so we're going to go have a look for port 30,343. So let's just do OC get nodes, and this will show us all the nodes in the cluster. We're going to do an OC debug node on master 0. And remembering we're going to go look for this port to see what's listening on it. So wait for that to start our toolbox container, and then we will go and have a look at the nodes, make sure they're actually listening on that port. There's going to need to be some changes because this OpenShift environment runs in OpenStack, so I will need to expose those ports so that we can reach them. But ultimately, all the nodes should be listening on those ports now with a node port. That's what node port means. It means that every node you have in the cluster will listen on that port, and it doesn't matter which node receives the traffic on that port, it'll forward it to this pod. So we'll do chroot to host and sstpnl grep for that port. So we can see that port, we have ovn-coup listening on that port, and if we look for the other one as well, 30,995, we can see that one's listening as well. Now, every node in my cluster will be listening on those regardless of where that pod runs. So, to access these, okay, so now we've checked that the ingress controller is running. It's been configured with our new ingress. The ingress exists and has the right ingress class. So now we need to use an external load balancer to load balance the traffic into those nodes. So we do OpenStack server list. I have this HAProxy VM here. So we're going to use this one. We're going to add another port to it so that it's on the same network as the OKD nodes, and then we're going to load balance traffic to it. So we do OpenStack server show. So they are on the network. This one. So we'll do OpenStack server add network to Fedora HAProxy. So now we've added a network to our HAProxy VM, so we'll log into that one. And we should see that it now has another interface on this network, so that's great, that's what we need. So what we'll do in another tab, let me see, get nodes, I'll show you, go wide. So we'll just take this. So we'll edit our HAProxy config. So let's just take this one for as an example. All right, so we want to configure another front end and another back end for OpenShift here. So let's take this one as our example, and we'll just paste that down here, and we'll call this one OKD. And we're not going to be able to bind on that specific port, so we'll do 1443, and we'll do for these servers, we need to change these, so we'll do it the same way. First one will be this one. Now the ports here are going to be different, and we need to go and check those ports again. So the ports were just copy these so that I have a copy of them. Put them down here as well. Okay, so the port, first one is 3343. Now this one, just copy this line actually, paste that twice, we'll do 1, 2. Next IP address is 3.164. Next one is 2.73. Okay, now that should be good. So we'll do systemctl restart HAProxy, and we need to be sudo. Okay, so I didn't like that. What didn't it like? Permission denied on that, so 740. That will fix that problem for now. Okay, so we've created our ingress controller's up. So what we want to do is just try and reach that ingress now. So we go kget ingress from monitoring, and we can see that it's here. So what we'll do is, we'll do curl. We're going to curl to our HAProxy load balancer on the port 1080, which is the one we set up in HAProxy. And we're going to use the host Grafana Nginx. So let's see what happens here. Let's remove all these V's, because that'll be noisy. Okay, so we're getting a response there. That's great. So let's have a look. So there it is. We can see that we're now hitting it on Grafana Nginx okd bne-home.net. So that is our ingress on the port 1080. So obviously you don't have to use port 1080. I'm just doing that because I'm already using 443 for my other Kubernetes cluster. But let's just take another look at that HAProxy config again, just to make sure we're clear on what needs to happen there. So we'll go down to the bottom. Oh. So these are the ones we set up. So I'll remove these. So these are the ones we set up down here, right? We set up this front-end OKD HTTPS, and we set up the front-end OKD HTTP. So for HTTPS, we're listening on port 1443. For HTTP, we're listening on port 1080. Then we just set the backends. So the default backend for HTTPS will be this backend OKD HTTPS. It's going to talk to all the master nodes, which are the only nodes in my cluster. I don't have any worker nodes here. And that's talking on port 30343, and that's because that was the port our service was assigned when it tried to assign the node port for 443. Now that's a high ephemeral port because by default you can't bind low ports below that in OpenShift, so you'll bind a high ephemeral port, and then we'll use that for our service. Same thing for HTTP. We're assigning 1080. You can do 80 if you like, if you're not already using it. The only problem is that I'm already using it up here. So 443 is for my Kubernetes cluster and 80 is for my Kubernetes cluster. So in the interest of not creating a brand new load balancer VM, I just wanted to use this same one again. It just means I couldn't use port 80 and 443. So once that is done, then you would systemctl restart HAProxy, in this case sudo, and then we'll go out of here and we'll do that curl again, make sure that works. So there it is, it's working again, and we'll go back here, we'll refresh this page, make sure this works. It does, and we'll make sure we can log into Grafana, and there we go. We can see we've got all of our dashboards available. If we have a look at the Nginx Ingress controller, the first thing we did was install this operator from Operator Hub. Then we went to create instance, which creates an instance over here of Nginx Ingress. That instance specifies all the options you're going to configure Nginx with. Okay, so through here we specified our Ingress class name, which was Nginx Ingress. We can go through, tune any of the resource things that you might like to tune if you expect this to be a heavy load ingress controller. We went down a bit further. So with the kind, you can specify either a deployment or a daemon set. A daemon set will deploy on every node in the cluster. A deployment will deploy the number of replicas that you specify. So if we go down a bit further, we can see that we changed the type from load balancer to NodePort. So NodePort means that it'll create a service that listens on every node in the cluster, and every node in the cluster, when traffic hits that port, they'll forward that through to your ingress controller. Replica count, so we can change the replica count to 2 or 3 or however many you like, but as I said, without daemon sets, it's only going to deploy whatever you specify as the replicas. In this case, I enabled debug just in case I need to debug something, but we can set that back to false. And then we just click save. So now what will happen in the Nginx Ingress namespace, we'll see that the pod will be recreated. So there we go. We're creating now 2 pods because I set the replicas to 2. And now that's up and running and working. So we go back here, we'll click refresh. We can see that it still works as an ingress. So the next thing you want to do, once you have verified that this is up and running, then we just want to check our service. We can see here that we created the service for, this is it here, and it's a type NodePort Service, and it has these port mappings. So you can see over here we map port 80 to 30995 and 443 to 3343. So that means that all of our nodes will be listening on those ports. So if we go down here, and we just pick a random node in the cluster and bring up a terminal on it. Now we did this through my actual terminal before, we can do it through the web UI as well. Chroot into host, and then sstpnl grep 3995. We can see that it's listening there on port 3995. Now every node in the cluster will be listening to that. So any traffic that hits it will be forwarded from here to our ingress controller. So once we have that, then we can go to ingresses and we'll go into the monitoring namespace, which is where our Grafana instance is running. And we want to create an ingress. So you can see here I just created a normal ingress, the same ingress you would use in any Kubernetes cluster. And we pointed it to the Grafana service on port 3000. And this is the name, arbitrary name we gave it. And because our default ingress class in OpenShift is the ingress to route controller, we don't want this ingress to be converted to a route. So we're going to specify the ingress class name of Nginx Ingress here. So once that's created, then we validated that it actually worked by checking inside our Nginx Ingress pod to see that the configuration existed. So let's go do that again. So this is one of them here. Bring up a terminal on that and go to etc nginx. So in here we can see that there's a monitoring Grafana ingress.conf file. And if we VI that, we can see that that is indeed our ingress that has been set up by our ingress controller. So once we verified the ingress was in place, then because this is running in OpenStack, what we needed to do was just verify that the traffic could actually reach these nodes. So we go back here and we do OpenStack server list. So these are our nodes. So we just check that the security group would allow that traffic, which it actually does by default, which is nice, but I'll just show you guys how to validate that that is indeed true. So security group here, this is the security group. We can do OpenStack security group rule list. So we can see in our security group rule list that these ephemeral ports that it created are actually already allowed in the ingress direction into our nodes. So that was really cool. So the next thing I wanted to do was use an external load balancer. So to use an external load balancer, I had to make sure that my load balancer, which is Fedora HAProxy, allowed that traffic. So we just did the same thing on my VM to make sure that it allowed those ports. So we added it to the K8s-BNE security group rule list, this one. So we can see that we added, where is it? So we added a rule here to allow those ephemeral ports into the K8s-BNE security group. So after that, then we just went and configured HAProxy, which we've already looked at. So hopefully that helps to understand how you can use Nginx Ingress in OpenShift. It's actually super simple. The only gotcha is really the security context. So to enable that, we did OC ADM policy, add SCC to user. In the Nginx Ingress namespace, the user is Nginx Ingress, and we just allowed it the privileged SCC so that it can access anything it needs. So that Nginx Ingress service account is created for you as part of that operator deployment. We can see that there. So that's everything you need to do to get Nginx running on OpenShift. So I will put all the artifacts of what we've looked at today up on GitHub so that you can reference them and create them in your own cluster and see exactly how things were configured here. I'll list all the versions below so that you know which versions this all worked with, because it might change in the future. I hope that makes it easier, and if you have any questions, feel free to ask below.